You're welcome back. In this video, I shall be treating relationship and mating systems in animals. You know, in human populations, we have all kinds of relationship. You have business associates, you have lovers, you have acquaintances, just all kinds of interest can generate various kinds of relationships among humans. But in animals science, when we speak about relationship, we are strictly talking about genetic relationship that comes as a result of genetic relationship. So basically, these relationships can be classified into two major components or two major arms, and these are like direct. We have direct relationship and indirect, or what you may call collateral. We have direct relationship. In this direct relationship, this is the relationship that is coming by descent, like from parents to offspring, from grandparents to parents and to grandparents, generally from parents to offspring. That is some kind of direct relationship. Okay. Then we have collateral relationship. In collateral relationship, it's like horizontal kind of relationship. This one is more like vertical. This one is kind of horizontal. That's the relationship amongst animals by reason of a common ancestor. These are animals that are like descendants, of a common ancestor, as it were. And then, but they took different lines under that ancestor. They're like downliners under that ancestor. So you want to know their relationship amongst them, their genetic relationship among them. Then those kind of relatives are called collateral relatives. So the relationship among them is a collateral relationship. This is like relationship between siblings, all right? Relationship between cousins, first cousins, that's because they have a common ancestor. Okay, but here we are talking about something like between parents and offspring. Okay, so the relationship between parent and offspring, an offspring, for example, can share 50% of his genes with his parent. That's a kind of a relationship. And then a measure of a relationship. And then collaterals here, there is a percentage of genes that cousins share among themselves, that full siblings share among themselves, or half siblings share among themselves, that distinguishes them or shows that they are more related among themselves than they do relate genetically to the rest of the population. So relationship in animal science is closely tied to the systems or the mating systems that produce those animals. This is why I decided to take the concept of relationship and mating systems in animal all at the same time, because the relationship cannot be divorced from the mating system that produce the individuals in question. So now, mating systems can basically be classified into two. We could say mating systems here, either they are inbreeding, or outbreeding. All right. Inbreeding is basically the mating of animals that are closely related. In other words, they have a relationship, genetic relationship, that is closer or stronger or higher than the average one within the entire population where they are found. So when you are mating animals whose relationship is greater than the average relationship of that population, that is the concept of inbreeding. Whereas outbreeding is just like the opposite of it. Okay, you are mating animals that are not that closely related, animals that are not related genetically. Then that is, you are doing outbreeding. Under this inbreeding itself, we have what we call the strict inbreeding, that's closed inbreeding. Here you are mating animals that are very, very closely related. For example, full siblings, half sibling, parent offspring. This is the concept of close inbreeding here. Okay. You also have something like line breeding. This line breeding, the animals are still related very closely, though, but the idea here is just to exploit a genetic merit of a certain ancestor in the pedigree. Okay, so most of those animals, they are still descendants of that superior parents, but you might just, it's milder than this. The effect of inbreeding here is a bit more tolerable than it is here. Okay, so you are doing an inbreeding, but on a softer scale. You are not the intensity is not high. You are just trying to make sure that the genes of a certain ancestor are still within a circulation amongst the family of that ancestor. But you are not bringing very closely related individuals there, maybe like full siblings or half siblings together. You are maintaining some sublines under that individual. Then you also have associative mating. This is where you decide, you choose, you insist on which animals, particularly due to some certain favorable characters, that must be parents of the next generation. So when you keep on selecting, insisting on particular animals to breed, that is a form of inbreeding. So this also gives, these are mating systems that are all under inbreeding. Whereas out here we have what we call outcrossing. We have outcrossing, we have crossbreeding, and we could have hybridization or species hybridization. Let me just quickly chip in. Outcrossing is simply the mating of animals of the same breed, but from different environment, or who are not related, who are not closely related genetically. They are of the same breed, quite okay, but they are from populations that are not related genetically. Okay, so it could be, let us say, any breed of animal. It could be a hosting cattle population in one location. You decided to pick a male there and you mate with a hosting cow from a different location. That is an outbreeding. They are not within the same environment. They are hosting quite all right, but they are not related. You get it. The main concept there is that they are of the same breed. So they are of the same breed, but not related. Then family-wise, So crossbreeding, on the other hand, it is when you mate animals of the same species, but of different breeds. So you mate animals of the same species, but different breeds. This is now crossbreeding. So staying on the cattle example, for example, you mate Holstein with the Angus cattle or the Brahma or any other breed of cattle. That is now outbreeding. Okay, that's the mating system. All right. Then you have species hybridization. On the other hand, is when you are crossing species, different species. Don't forget, here you have the same breed, but different populations, different families within the same breed. Whereas in hybridization, we are talking about the mating system that crosses animals that are of different species. All right, just different species, goat and sheep, lion and tiger, horse and donkey, etc., etc. So those are the various kinds of breeding systems that can lead to all these relationships. Now, what factors determine relationship? We are looking at factors that affect relationship. Okay, so factors that affect relationship in animal science. Okay. In animals. Top on the list is something we call population size. Okay, that's effective population size. Population size. This population size, this effective population size, there is a minimum population that is required to maintain the gene frequencies from generation to generation, to make sure that the frequencies of genes are the same as they were in the parent generation, as they are now in the offspring generation, and as they would continue to be in subsequent generations. But when the population is becoming smaller, then it is more vulnerable to fluctuations in gene frequency. So this size of a population is a major factor in determining relationship. So the smaller the population, the more you would understand that the animals or the individuals within such a population will be more genetically related. But the wider the population, the less their degree of genetic relationship. Then the other one is skewed mating ratio. In animal science, we maintain a mating ratio. Maybe you could say, for example, 1 cock to 10 hens, 1 cock to 7 hens, or 1 bull to 8 cows. And so that's a mating ratio. So when the mating ratio is skewed, especially if it is overly skewed in favor of a certain sex, if you just have like 1 cock and several other females are being mated to that cock, you would know that the genes of that cock would circulate more amongst the offsprings, more than those of any particular dam. Okay, so this will now, the relationship of the offsprings from such a mating arrangement will be, the genetic relationship of such offsprings will be greater with their father. You see that the genes of the sire will be more in circulation in that population than any other single dam. So when you skew or you over skew a mating ratio, you are directly affecting the genetic relationship. Then the other one is selection intensity. Selection intensity, which is closely related to this. This is where you place an undue pressure on particular parents. Maybe you deem that they are well-performing parents. So when you place undue pressure on those parents, that by pressure we mean a selection pressure, that is, you are repeatedly giving that animal overly and above an advantage to contribute its genes to subsequent generations more than it would have been able to do if there was no selection. If there was random mating, it wouldn't have been able to achieve. Then, for example, you could place selection intensity or pressure on a male if, for example, you are using artificial insemination. You collect semen from a male. That singular ejaculum is what it could have mated 1 individual, 1 dam. But by collecting semen from that male, it gives that particular male opportunity artificially by you, the breeder now, for it to now mate several other males. So using such a technology as AI could place pressure or selection intensity on a male. And the male now will sire more offsprings than it would have. The same is true when you begin to do things like multiple ovulation from a female, from a dam, multiple ovulation from a goat or from a sheep or from a cattle that generally could have produced 1 calf per parity, but by superovulating it, it may produce 10 eggs or even more. So when you have those 10 eggs and you distribute to other surrogate mothers, you recycle that choice female again. So that quick succession of recycling and those multiple ovulation tend to place selection intensity on that male, on that female in this case. So these kind of factors will increase, meaning that the offspring that will be coming from such a population will be carrying more of the genes of that female that was being multiply ovulated. So these are some of the factors that affect, relationship in farm animals. So like the videos and share, as I encourage you from the beginning. I will see you in my next class.